let's take a look at character controllers in more of an advanced way. So you can run a character controller with simple move, and that's great. It simulates gravity, can do lots of stuff. It's not designed to mix with a lot of more advanced features. So I wanted to show you how you can build a more flexible, advanced character controller. So I built a little scene here. I'm just going to show you. Technically, right now, the only piece of logic is making this thing spin, which is mesmerizing. I know. You can see here. Just stare. Yeah, forever. Right? But anyways, point is, if this is our player and we have a capsule and I got just a character controller on it, nothing else. It's all it has. And we can add an FSM, and we'll call it movement. And I'm going to use get axis vector because I like this input system. We'll give it a little bit more speed. I'm not going to do relative to. I'm just going to keep the camera stable. And I'm going to make a variable called move, and it's a vector. Now, if I did simple move, I could just run it kind of like that, right? I would have to up the speed as well. And just that alone allows us, like just those two actions, will allow us to move around. And as you see, we have some gravity. And everything kind of works. So let's slow this down a bit here for a minute. And you can see as we go over the cylinders of plate here, right? Like these kind of hugging the terrain a bit, right? So it's going up and down. A little floaty. It's a little floaty. But okay, cool. So let's get rid of simple move, because we're not doing simple move. We're doing more complex stuff. We want to go deeper. So if I just go and input it into move, and it's now at 4 on this portion of the input, I can see various things. We can see in reality it is virtually the same in this, except we're not getting that same dropping. In fact, now I'm hovering in the air. If I climb up here, like, I don't have gravity. Doesn't matter if I stop or move. I'm floating through the air. Woo, look at me go. And we don't want that. That's crappy. So how do we fix that? Character controllers can be really picky. Won't get into too much detail about that, but they can be picky. They don't like being controlled various different times at the same time through different actions, yada yada yada. So if this FSM, if that's all it contains is this one state and it's always going to move, this thing's happy. It'll always be happy. Well, that's great, but how do we add gravity to it? You know, I could be forcing it down or doing some crazy shit. And I can make another FSM and add to it. But what I'm going to do is I'm going to vector 3 add. Now, where we put these things is really important. So I'm going to take move and I'm going to add a variable called gravity. And I'm going to go every frame. I'm not going to go per second, just going to go every frame. Okay, so now what if I make another FSM, and we can even just call this gravity, and if you want you could also template this and actually add it into the movement thing. I won't bother going that far into it. This will kind of give you an idea. So what if we set FSM vector 3, we're going to go into our movement and we're going to take gravity and we're going to use a variable. So we're going to use a variable called gravity as well. And let's do that every frame Don't need to do it for every frame right now, but we're going to do it every frame. I'm going to give it a default value of -9 on the Y, which might not be enough, but you'll see what happens. So we now have an FSM that's literally just controlling gravity. And this guy, he's just takes his vector and he's going to add gravity to his vector, and then we apply it to the controller move. And you can see he now has that. He's hugging the world. He is now using gravity. I can move him around just the same, and all of a sudden now we have gravity. Very simply, just with that small thing, right? Okay, so that's cool. Why not, right? All right, so what if we go to gravity? Because if we wanted to add a jump, we don't want the gravity to necessarily screw around with our jumping. So let's just do a get key down. And this could go deeper with doing ground checks and stuff like that. I'm not going to go that far into, we really don't need to stuff. So we're going to do a jump. And actually, no, I'm not going to do that. I'm going to go, I just prefer to do it like this. I think it just looks cleaner. So a jump. So what is gravity? Again, we're going to be setting the value here. But I want to interpolate the vector. No, let's move down here. So we're going to go from, and I'm going to go from a hard value of, say, I don't know, we'll say 20. And we're going to go to another hard value of -9. I think the actual gravity was like 8.89 or something like that. I don't know. And then we can justify a time to it. Store it into gravity. So when this state happens, the gravity is going to jump up to 15, and it's going to go down to the -9 pretty quick. So when it's done, let's just do, just call it normal, I suppose. And I'm going to tack it onto there, so when he's done, go normal. Now, just with that, now this is also where you can do like falling mechanics and stuff too. So if I hit space, we have a jump. Nice and simple. And the beauty part is, if you've ever played with a controller and you have those issues where you're jumping and you're doing stuff, and you jump on a platform and all of a sudden it skyrockets you off into space, this will prevent all of that. Right? But now that's pretty solid. Works pretty well. So listen, now this could be a template that you just stuff into this movement. So let's leave that one for now. Let's add more. What if we wanted a sprint? Okay, well, what is a sprint? And the easiest way to do that one is a vector3 multiply. And we're going to move this up, and we'll stick it there. And we'll call this sprint. It's our sprint modifier. Oh, wait, oh, sorry. Move. Our sprint multiplier is a float, because we do it here every frame. So I'm going to default it at 1. Okay, so now we have sprinting. So let's add an FSM to control sprinting. And this could just be a get key down. Let's do left shift. Left shift, and let's say sprint. Okay, we're sprinting over, so we go over here. Now let's do get key up. You could always just get key and do a bool test. Might be a more solid solution, but I think this will work fine for now. And if it's up, let's go back. All right, cool. So now from here, all we have to do is set FSM float in our movement sprinting to 1, and over here we can set it to, well, we'll say 2, or you can go 3 or something. Now we also could interpolate that so it's not just a jarring quick thing. We could actually interpolate from, you know, say our current speed to, you know, 2 over half a second. So it'd be more of a kind of a gradual, he's picking up speed, kind of like what I did with the gravity. So there we have movement, and if I hold down shift, we're moving much faster. See, press shift, let go of shift, press shift, right? And just in case it's not that visible to you, let's jump the speed up to 4, and that easily could be a variable if you wanted it to be adjustable, right? So there, now we have sprinting. So we also could do crouching. Crouching wouldn't be from, you know, 1 to 2 or 1 to 4. It would be 1 if it's false, and then 0.5 if it's true. So we're cutting the speed down, right? Very easy to add in something like that. So one of the other things is, what if we add, let's do another add, and we're going to add to our move, but now we're going to make a new one. We'll call it KnockBack, and we're going to add KnockBack. So the KnockBack will be a little different, right? So let's go into here and let's add a KnockBack event. Make this one global. And what we're going to do is, if we get this, it's actually going to come from an event. So let's do one of these. Let's do from, we'll just call it from, how about? It's going to come from a game object, and this is the thing that hit us. All right, cool. So we would need a direction. So let's do vector 3, no, let's do a get position. We need 2 of those. And then now we need a vector 3 operator. And then we'll need a vector 3 multiply, but we'll get that after. All right, so let's order this a little better. So that needs to be, the get properties need to be at the top. So we're going to get, say, the player's position. We're going to get the position of the thing that hit us, the thing's position. We're going to now operate on that. We're going to say the thing's position, might have to swap that around, but we're going to subtract these 2. And this is now our direction, which could give us a bunch of different results. So we want to normalize this. And then we're also, after that, we're going to vector 3 multiply. So we're going to normalize it and then multiply it. So we have a consistent, like, knockback. It's not going to be like, oh, sometimes it's this, sometimes it's that. Now, you could add random values, don't get me wrong. So we're going to take the direction, we normalize it. We take the direction, now let's multiply it. Let's go, you know, maybe 8. And we can play with that number. All right, so we have a bunch of things happening here, obviously. But in the end, we end up with a directional vector here. So all we now have to do is, let's finish this and just go to a new state so it's nice and clean. Let's set FSM vector in our movement, our knockback, to our direction every frame. Then let's interpolate, because because we don't want that knockback to be permanent. So we're going to go from direction to 0, store it in direction, and then, you know what, we could probably even do a finish on that one. And just go to a blank state. So that's really all we have to do. So, okay, let's look at this thing that's going to be knocking us back. So he has an FSM that's just spinning him. Okay, cool. I'm going to actually turn him into a trigger. Again, you don't have to do this. You could do the normal collisions or do brake acid, whatever. So let's do how we're actually going to do this. So he needs a trigger event. So on trigger entry, he's going to collide with the player. So, okay, first thing, let's make sure our player has a player tag. So that actually works. So we're going to store collider. So we know that we've hit, or what we hit. And now we're going to go hit. So what are we saying we want to do? We want to get owner, which technically this could be in the start state. We don't need to get the owner every time we hit. It's fine just once. We'll just call it, you know, self or something like that. I mean, nothing special. So anyways, so at the very start, we're going to get our owner stored in the cell, so we have ourselves as a variable. So now we're waiting for a hit. A hit happens. What do we want to happen? Well, we want to set event properties. The from. We know it's type game object. We're going to say it's our self, and we want to send event. Below the set properties, and we're going to send an event, and I'm just going to drag the player in for a second, just an easy reference, so I can use these. We want to go to the knockback FSM and choose knockback and swap this back over to the player hit, and then after that let's just go back and wait for another hit. Alright, so I think I got everything there. I don't think I forgot anything. Maybe I did. Well, we'll test it. Let's see what happens. So this is just a trigger, and if I come down, I can see it's pulling towards him, so we're going the wrong direction. So that's an easy fix. Not by that, it'll be on the player. So we need to reverse this operator. So we want to go with the player's position, subtract the thing's position. The multiply seemed a little light, so let's take that up. The other thing is possibly, what if we wanted a bit of a y? What we can do is say a vector 3 add x, y, z. Put it above the normalize. Let's go with direction, and let's just add a little on the y. Then we'll normalize it and multiply it. Now keep in mind, because we're triggers, they are limited to speed. I mean, if I was using a physics connection, be a little faster. But you see, like once in a while it skips, and that's because of the speed. But it is technically working. So let's just adjust that some more. Let's go. Let's add a little more to the y. Let's go like 2. You know what? Let's go 3. Let's go crazy. Let's multiply by like 25 though. And let's take this guy and actually slow him down a little bit. I think 300 might be a little fast. And now we have a So now, and that's all triggers, right? Like it's not, technically it has no physics to it. Once in a while it is skipping over, it's still a little quick. Downside of triggers, right? We don't have any altitude yet. Normally with the gravity, this being -9, you kind of have to overpower that in this situation. So we might have to ram that up if we want a little more Y on it. The other thing is often you could also, let's take it to 15. You could also add in like a ground detection, so you actually have a little less gravity. There we have. Now we have a bit of a hop. A little too much hop. Now it's not enough backwards movement. It just takes a little bit of playing with, I suppose. So let's bring that down a bit. Let's bring that down to 12 and take this one up to 35. So what do we have? We have moving along ground. We have jumping. We have gravity. We have sprinting. And now we should have knockback. Now I'm doing the trigger, and that's why it's got some issues with it sometimes missing. So if I actually change that, like if I went to this and took trigger off, the capsule has this. So technically I can use physics because it's like having a rigid body. But then I would have to alter this, because now if we don't use trigger event, we'd have to use collision event. If I could spell at all. And God knows if I haven't learned that by now. So we're just going to use those same events. The player hit. We don't need to store the force. And you could if you really wanted to. So we didn't really change much. It's just the difference between trigger and non-trigger collisions. The non-trigger collisions should be a little quicker though in the ways of picking it up. Well, we also have that effect now too though. But that should have, let's see, is that triggering? No, it's not hitting now. Why is that not hitting? Alright, you know what? I'm going to add a rigid body to this. It's kinematic. Put it on continuous. Which isn't necessarily a good thing to have rigid bodies on a billion different things for performance. But I mean, he should. Picking that up, I think it will actually work better with the trigger. Is that for some reason, unless I screwed something else up. Yeah, he is just not liking that detection. So, player, and that, getting rid of that. You know what, I wonder if I can get away with this. Controller. Collisions. Linear step velocity. I'm pretty sure there is a hit info. Yeah, that's not going to help us. Alright, so that is player. I really don't want to put a kinematic. I suppose I could, but prefer not to run these things on the player. Now that shouldn't actually affect anything on the player because everything else is being controlled. Like you can see, it's still gravity. Everything's still working because we're running everything through the character controller. So the fact it's a kinematic shouldn't matter. But now we should have unless I don't have. Let's check our physics. Default contact pairs. Enable all contact pairs. You silly thing, you. There we go. Now it's working. Right, so there's more of a physics approach, and it'll be a little more accurate. Now, with that said, I mean, we're also hitting, it's kind of pushing us around as well, which may not be the most ideal solution. Maybe it is. No. But it's, I mean, we could definitely use a little more force in the way it's hitting us. But overall, it is working. So let's just go into this guy, go into our knockback, take this multiplier. I'm ramming this up to something crazy. I'm going 75, bringing this guy down to 11. What? I said 11, not 1. Lowered 100. And now we should have, that should hit us a little better. This should actually knock us back. We should go flying a bit, right? So there it is. But it's a little kind of popping up, right? And we don't really want that. So let's fix that part up a little bit. So here we have it going down by 1. Let's take that and stretch that out to 2. Now let's even go 3. Right, and that's going to fix kind of that length that we're traveling, because that's kind of where right. So now his Y is up a little high. So let's fix that a bit more. So let's go into knockback and let's just bring that stuff. Let's bring this one down to a 9.5. Take this guy to a 60. Let's take him back down to a 50. And I'm going to take this thing over to like a 5. To which you could also adjust that with is grounded. So if he's grounded, maybe it's a little quicker. That's looking a little better. Now the actual falling, kind of, I want the gravity to hold a little better, right? So that's kind of where here the normal gravity would be less. Like you'd want to go to -9, fair enough. But when you actually hit the ground, so you have to do kind of a bit of a grounded check in here, right? Like if we did, we'll just do a ray cast, nothing too crazy. Won't bother with the sphere cast. So space self, let's go 1.1. Direction, let's go downwards, world, and we can just do a hit event. We'll say grounded. Now you'd probably end up building an entire FSM for grounded, so you could just do a bool test compared to this maybe, but this will work. So once this is grounded, I guess we can just use the normal. Actually, we don't need to take this one away. Go to the normal. So now in normal, we can now set vector 3 value here, gravity, and we'll just go something smaller. right? Like -3 maybe, or -2. And hopefully we don't have too much floatiness if we're going over bumps. So now the only issue here, we would have to put in some more ground checks for if we're in that state and go to a falling state, which is actually kind of nice because when you do it that way, you can get the coyote time and stuff dialed in, right? That's way too slow. But that's because I am most likely grounding pretty damn quick. Oh wait, no, yeah. So that's because we're doing the check here, but we're not doing it here, right? So that's kind of the issue. Is now we're at -2, and that's kind of how it goes. Now over here, we still have that bit of a grounding stuck. It's a little floaty. It might be okay. You can probably go with a point or -3 maybe, but it's when you come here, right? See, like the actual jumping. Oh yeah, see, he's hitting that right away. So we would need a delay. So we could do a finished. And then do our raycast in the finished. And that should take care of that issue, that instant travel back and forth. Right? Yeah, just like that. Like I said, now we could probably go to -3, but what we need. Oh, see, that comes a little quick. I have that raycast, I think, a little far. Yeah, let's go 0.55. So what we need is a raycast here in order to kind of tell us if we're falling or not. So I'm also going to put the player on a player layer so I can actually mask out this ray just in case that's going to mess us up. So we don't want to be hitting the player, so we're going to invert it and hit everything but the player. So I'm also going to come over here and add it here. Right, so here, but now we're not going to do an event. We're just going to take the event away. But let's test something here. So if I'm standing still, this should be true if this distance is the right distance. And we can turn debugging on to see that. Right, so it's false. So if I up that, yeah, see, which is why I went to 1.1 in the first place. So 1.1 gives us the true. So I'm going back to 1.1. So I think this probably was messing us up with that mask. Should fix that. So ideally what we need now is if we have a no hit event, we're falling, or to fall. So it'll be much like this one. But obviously we don't want this interplate to go from a positive 15 because we're falling, we're not jumping. So let's go from 0 to -9, and then we can raycast down. This will also prevent jumping while you're in the air as well, if you're falling, right? So if I jump, and now if we do this, he's in a falling state for some reason. I'm going to have to move that out a little farther. But that's starting to feel much better. That will allow us, now we have a little more here, it's kind of more of a, I mean, the altitude we're getting is pretty crazy. So let's fix that up. So this guy, because the way he works, he's just going to need a bigger, let's go 1.3. Alright, so that's working. Now let's go back to the knockback. And I'm going to bring this guy down to like a 3, 4. Multiplier down to like a 30 again. Take this guy up to a 6. Kind of stretch that knockback out. Make it look a little smoother. That's better. And that's with, yeah, we're using collisions now, right? Yeah. So you can do the same thing with the trigger. Like I said, obviously, if your moving object is a little fast, the trigger isn't the best option. It gets skipped. But there we have more of a much nicer knockback. Right. So just kind of a matter of, you know, how long we want that knockback effect to really affect us. And this could be interrupted with a ground check. Like I said, like if you're at 7 and you hit the ground, maybe you know, deviate from it and bring that down. Take this guy down a little farther. Let's see if we can get away with 20 and still be far enough away that we're not like instant like thump thump thump. Yeah, that's looking pretty good. So the only downside of the collisions is that the getting pushed, which I mean, in one hand it looks kind of nice, a little more realistic, I think, but on the other hand, sometimes when you get caught and it drags you a bit and then throws you, a little iffy. Which is kind of why I went with triggers in the first place. But you also could do ray cast. It would work just fine, because then you're not actually physically connecting with them, but you still have high accuracy. So we have sprinting, we have jumping, and all those things will actually compound onto each other, right? Like, it's not like, oh, I'm in this one state so the other ones won't affect me, because everything is feeding into the one FSM. That's really the whole beauty of this entire thing, is you could add these for all. You could add different knockback effects. Maybe that's multiplied by a strength value in this or something, I don't know. But everything is simply being done, all the logic is in this one FSM, in this one state, and it's just a matter of, do we add or multiply or, you know, even divide, I guess. But normally multiply and add, right? So we're adding gravity, we're adding our knockback, we're multiplying our sprint. I said you could also multiply a crouch. I don't know what else you would have for possible things of that you could add. We have our speed here. You could also do crouch and sprinting based off this speed. I do actually have another idea, because I know this comes up quite often. So let's look at dashing. Oh, dashing. So movement, let's add a new vector called dash every frame. So let's just add another FSM. Called get key down. So we get key down. Let's use, oh God, I don't know. Let's use R. That's a stupid letter for it, but whatever. It will work for what we want. Dash. Now we could, there's various different ways we could do this. Now what if we want to dash in the direction we're moving? So what we're going to have to get is, we need to know what direction we are moving in. So we need to go get that vector. from our movement. Let's get the move. This is our movement. Okay, cool. Now we know the direction. So because we don't know how it's being modified by all the other stuff. So let's normalize it. We just want the direction. We don't care about the magnitude of it. We just want the direction. Now let's multiply it by our dash value. All right, let's multiply that by, and we can now say 20. Sure. You can take that kind of wherever. And now all we want to do is let's do a set FSM vector 3, and we're going to go into the movement. We're going to set dash to move every frame. All right, so but it's not the same move, right? This is we've grabbed the normal movement. So we have a kind of a different copy of the movement, and then we're going to normalize it, multiply it. We make our own little thing out of it based on the direction of the movement. And then we're just going to throw it back in. So then all we're going to do is interpolate. And we are going to interpolate from move to 0 and maybe over half a second and store it back into move. And then when it's done, we'll come over here. And when we come over here, we just want to make sure, it should be there anyways, but we are going to make sure anyways, not every frame, that the dash is 0. That's it, right? So that's our dashing FSM. How dashing of it. So now if I'm moving, say, forward and I hit R, I get this little burst of speed. Doesn't matter what direction I'm going. If I let go of directions, my dashing is nowhere. That could be stored. I mean, you could always run another variable in the movement FSM, just always store the last variable and just not update it. No idea. But there is, with having an R, like, what a dumb button I did. So we could say, let's take this up to 30. Let's take this up to 0.75. Give that a little more of a dash. I can also dash in the air doing this way. I mean, if you wanted to stop that, you would have to run ground checks, which is why, like, normally for ground checks, like I just put those 2 raycast in, you would probably have an FSM dedicated to ground checks, and then everything else that needs to reference it would just be a bool test. But there is dashing. Let me go 1. And that's based on not caring about grounding, and it goes in the direction that we are moving. And if you wanted to really store that value, you'd almost need another FSM to actually store that value. So you always have a locked value. I won't get into that right now. So there I think though is a pretty good solid if you want to build a more advanced controller. We have gravity, we have sprinting, we have knockbacks, we have rigid bodies, we have dashing, and it's on a character controller, so everything's adjustable, right? And if you want to know what actual gravity is, merely go into here. That's the gravity. It's almost 10. I thought it was 8.9 or something. But anyways, 9.81. That's what they're using for gravity. That's the actual norm. Right. So, But that's a pretty solid controller. Like I said, and you could jump around. We can now dash and do things. I can dash in the air, right? So that's all stuff that you would have to do. Well, I can even dash going upwards if I time it right with my jump. You know, and if you don't want that, just zero out that Z, right? Like we can modify any which way we want. Like we're just getting the dash and we normalize it. We could set vector 3 x y z. Right, we could take that move and zero out its y and then normalize it, and then we can't do that on the jump. Maybe you like that, leave it. I don't know, totally good. But we can modify things a bit as long as things go in order. Things go in order, you're good. But so now I really don't know what else to add. I mean, there's movement, there's gravity, there's sprinting, there's dashing, there's knockback. What else could you possibly want out of that for physics, other than possibly climbing up walls and stuff? Which maybe I'll have to do that sometime. It's a little bit of a bigger. That one's definitely a little bigger. Because you have to, you know, tilt the character. You have to rotate the character. And of course adjust gravity, right? Which in our case, gravity is this. And we're not using the actual gravity, we're using this value. So we'd have to modify our gravities. But anyways, probably long enough for a video. It's probably pretty long actually. I didn't mean it to go that long. But there is a more advanced character controller that you can build on. It's relatively easy to set up.